Azure Digital Twins has been in GA for some weeks, months now. Andy Cross from Elastacloud is here to share his first experience as an MVP, but also as someone providing solutions to customers. He actually also will tell us how he is applying DevOps to digital twins. That's today on the IoT show. Hi, everyone. This is the IoT show. I'm Olivier, your host, and today I have Andy Cross from Elastacloud to tell us everything about their experience using Azure Digital Twins. Hey, Andy, how are you?
Yeah, very good. Thank you. Thanks for letting me on the show. I'm a big fan, and it's a real pleasure to be here.
Thanks. Well, thanks for being a fan. And for everyone actually watching, you can subscribe to our channel, and as well as get the notifications for future episodes of the IoT show. Thanks for the cue here, Andy. So Andy, before we get into your experience and Elastacloud's experience with Azure Digital Twins, first, you need to tell me a little bit about yourself. Who is Andy Cross? What are you doing in life? Where are you calling us from? Those kind of things.
Yeah, sure. So I'm Andy. I'm in the UK, and I'm currently in Milton Keynes, although I live in Kent. But I'm in Milton Keynes because tomorrow the company's got an away day, and we're going to Bletchley Park, the home of computing, where the code breakers were in the Second World War. We're going to go to the museum, the National Museum of Computing there, which Elastacloud sponsors. We're going to have a fun day learning about old computers and then sort of sharing about new computers and cloud computing as well while we're there. So I'm currently away from home. Hopefully we will have a good internet connection, which is one of the biggest problems in the 21st century. But I'm up in Milton Keynes today. I'm a 9-year Azure MVP, which nice. I found out today when I went and looked at my MVP profile to try and work out what number it was. So not quite double figures there yet, but I'm proud to have been a member of the MVP community for quite a long time.
Well, thank you for that. Actually, it's something that is a great reward for your contributions to sharing your knowledge, your experience using Microsoft products. We do appreciate that a lot. It helps. So we will talk about Elastacloud, about smart building management. How did you come to be in that space?
Yeah, so I mean, Elastacloud is a business that's been around for about 9 years, and it's really a data consultancy. On Azure, we were born in the Azure cloud. We've done everything really there is to do on the Azure cloud, but we focus on data and on data platform. And I've always really loved IoT. I've loved devices. I've loved electronics for a long time as a hobbyist. I've done things with the Netduino platform and .NET Micro framework a long time back, with Arduinos, with Raspberry Pis, with quite a lot of the consumer and hobbyist type of electronics personally. So when the IoT services came to Azure, and obviously we started off with IoT services on top of things like event hubs and service buses. There wasn't anything that was really an IoT service. And when the real IoT services started coming on board, like the IoT Hub and IoT Central and other related things to those, we as a business got really excited about a new way to get hold of data coming in as a stream, data related to the real world. And we thought we could use a lot of the things that we already know about Azure and about data on Azure and data in a cloud environment to help our customers in a way much more connected to the real world, to the physical world, by pulling in this telemetry about the real world, giving it context and bringing it together with like business data to try and give like a holistic view of a business and really to do another phase of digitization, getting rid of even more paperwork than has happened in the past and giving people data that they've never had access to before.
Nice. This is very interesting here, Andy. So You've been using Azure Digital Twins. Can you, so you described Elastacloud. I know you came up with some slides that really illustrate what the business does, what things are about when it comes to Elastacloud. So yeah, go through that. Tell me more about the company itself, about your services, and then we'll talk about your use of Azure Digital Twins in that context.
Okay, well, I'll just pull up the slides now.
Okay.
Okay, so Elastacloud has built a piece of software, a product called Elastacloud Intelligent Spaces, which is a digital twin used for managing intelligent facilities. So that's buildings, it's any kind of space that a company may have to try and get more information, granular information about that business setting, to try and bring that in to operations, to try and improve an overall business effectiveness or efficiency. One of our customers has deployed this and successfully managed to get £10 million a year of annual savings from predicting and preventing water leaks. And they do that by taking IoT data as a stream and combining it with information about the buildings and BIM data in a spatial intelligence layer, and bringing all of that data together to allow geospatial analytics over the top of data related to that building to predict where there's going to be failings, predict where there's going to be floods, to bring maintenance into the story early so that we can get ahead of problems. Water leaks themselves tend to be quite small, but they tend to just cause huge amounts of damage because they're not picked up for a long time. So they soak through and they soak through, and then eventually they ruin everything underneath where that water leak is. So very, very simply, by working out where there's a problem geospatially and getting that information to the employees of the business in maintenance and giving them the full context of when it started and where else might be affected, we can help people save money and make a more intelligent space by getting ahead of problems in a relatively advanced way with predictive maintenance and preventative maintenance as well.
I like the way you position things, saying that you're putting data in context and bringing the data in the context of the building management story. And that's also funny you use the example of a water leak, right? Because the way I like to put things is that you guys are building very nice plumbing on top of our plumbing of the Microsoft services and platforms. So the area you guys are expert in allows you to really deliver that service to these customers. We're operating, we're owning these buildings, and you're a smart company, you're smart guys, and so you don't want to reinvent the wheel. So you've been using, as you were saying, Azure services.
Yeah.
Can you tell me more about specifically why Azure Digital Twins? Because at the end of the day, if you think about it, you have the wealth, you've been working with databases, and why not developing your own digital twins platform? Why using Azure Digital Twins as a service in your offer?
Yeah, that's a great question, and I think that there's an interesting difference between what a digital twin is and what Azure Digital Twin is. A digital twin is a representation of reality, bringing data together and solving business problems with that by representing reality and giving people a way to interact with it. And it encapsulates analytics, it encapsulates interfaces, and it encapsulates data. And Azure Digital Twin is a database and a type of database that you can build a digital twin on top of in a really compelling way. So when we look at what an Azure Digital Twin is, it's effectively a graph database. And there are other graph databases around. There's other graph databases on top of Azure. But it stands alone as something which is really designed and very compelling in an IoT scenario, at least for me, because you have this graph database, which, like all graph databases, puts relationships as equally important as the entities that are connected by those relationships, and brings in like traversals between things, which allows us to map how we think and how we understand reality. We can map that in a data structure quite easily. But where it becomes quite unique, and where Azure Digital Twins is quite unique, is it also combines telemetry as a discrete type of data which flows through the data store. So you've got both data at rest, which describes your building and the rooms and the levels and how all those things are connected. Like these rooms are on this level and this level is in this building, and this building is part of this overall real estate site. But then you also have telemetry, which can go on there and can flow through that twin, effectively have events coming directly from an IoT stream that you can connect onto that database and enrich. So a message might just come through and it might just have an identifier, like for argument's sake, like say room number 1, temperature 25 degrees or something like that. A very simple message, but as it flows through the Azure digital twin, you can pick up the fact that it's in room number 1. You can then work out that room number 1 is on level number 2, and then you can work out that that's in building number 7, and then you can also work out what else is in that building and what else are on other levels, what's above it, what's below it. And you can use that to build really intelligent queries that understand geospatial type information in a very similar way to how people understand it. It makes your whole data understandable. And when you start making it about geospatial intelligence, you fix one of the problems with IoT. And one of the problems with IoT is that there is a lot of silos of data, a lot of vendor specialized silos. So like your burglar alarm system writes to a burglar alarm database, and your water pressure system talks to a water pressure database. And maybe the vendors for those two things end up giving you BI reports over the top of those two things. But if you ever want to work out whether those two things are connected, for whatever reason, or you want to build like an enterprise data lake that brings everything together so you can work out historically how everything is related, then actually the problem becomes that because these are in silos, you've got an integration piece of work that you have to do yourself, which is all at your cost and all at your expense, and you have to have a team of people able to do that. Whereas if you have a digital twin in the middle of all these feeds and all these data feeds, they're implicitly joined by the ontology or the shape or the schema of the Azure digital twin itself, and we can get understanding about all these different data feeds, and that allows us to break down these silos and actually make a lot of sense and bring a lot of context to IoT streams, which historically has been a very difficult thing to achieve.
Nice. So many different sources for data and many different customers as well for you, right? Hopefully a lot. And that actually forces you to have this graph database that is available in the form of Azure Digital Twins. But also, I figure, and this is something you discuss in your blog post that we will point users to at the end of this show, you discuss the notion of a version of models, because you talked about ontology right now, but then there's another thing, which is the Azure Digital Twin Service itself evolves and gets new features and functionalities. So at your level, I know you've been creating, a model lifecycle management tool framework because of, the inherent nature of these models and the services like Azure Digital Twin. So tell me more about, how you came to creating that device model lifecycle management framework.
Yeah, absolutely. I've got a slide that describes some of the thought process around here as well. So I'll just pull that up.
Okay. Let's go.
Okay, and the reality is that with any new service, and when the ADT, Azure Digital Twin, became generally available, it was a very exciting and great day for us. But when any brand new product comes out or a new version of a product comes out, there's always this lag in the ecosystem for being able to build and use tools around the edges of that brand new service to be able to really use it in production and have control over the top of it. So when you've got something like an application, like our application is, like Elastacloud Intelligent Spaces is, and you try and put it into production, and maybe you've got multiple customers, each with their own version of Azure Digital Twins, you have to start making sure that you can rely on the schema or the ontology that's deployed into those environments before you start trying to call it. So for anyone who's not super familiar with what the ontology sort of metaphor is, if you think about like a SQL schema or something like that, it's the table names, the table structures, the number of columns and things like that that are in there, and they have to match with really what you're trying to insert into them. Otherwise, just like in SQL, you get a problem in Azure Digital Twins if you try and insert into a type that isn't already specified. So whilst there's a semi-structured nature to Azure Digital Twin, it's not fully unstructured. You have to have these models available that define the shape of what you're storing inside that database. So if you're going about it in a sort of primitive way, you might have this flow where you're creating these definitions, a bit like your SQL tables, and they're called digital twin model definitions. And you have like a developer who's doing that. You create these JSON files, which is how you describe them. So it's in like JavaScript object notation, a very sort of common data structure, very easy to understand. But it's one where you work with them on disk as files, JSON files, and then typically your developers will work on them. They'll go through like a dev loop. They'll add new properties as their software requires it. They'll create new versions of those files. The models themselves have got versioning baked into them. Like there's a name, and then there's a semicolon, and then a number, and that number is the version of those files. And as you're sort of going through that, you end up with lots of these files being created. And if we want to push those things into production, we want to do that in a mature way, not in a way where we're hacking at it with a couple of developers trying to get some work done really quickly, but instead we're trying to do it across multiple customers. We're trying to release versions of software that have versions of the dependent digital twin definition language in there for us to be able to use those models. But we want to keep all of that in sync. We need to go a little bit beyond that thought process. We need to manage our production estate. We probably shouldn't be accepting that we've got developers who can just log in and do that stuff, because humans make mistakes. And one of our philosophies at Elastacloud as a data company is, if you've got people touching production, then you're doing it wrong. And actually, you want systems to be interacting with all of your environments, really reliable, automated systems all the way through, with infrastructure as code, but also everything being automated in terms of deployment, and that deployment running as often as you can, making small updates, keeping everything in sync all the time. So we should have a zero or very, very low trust environment where actually we can't go in and just make mistakes and do anything like that, except maybe in a support setting, but not as a business as usual. We shouldn't have developers touching production. If we've got multiple different customers as well, we don't want people to have to remember different usernames and different login methodologies. That's just going to be a problem for us. If we have one customer, but they've got a very, very large digital twin, or perhaps they want some of the digital twin to be represented by something in the United States, some to be in Europe, some to be in Asia, then they want to be able to effectively partition their data, using and leveraging the scale of the Azure cloud to have the data resident close to the teams that are using it. And you would need to make sure that, again, multiple databases for one customer are in the same place. And how do we do all that? Excuse me, how do we do all that and keep all of our versions in software in sync? So it's not just the version of the database, but the version of the database and the code that is used to affect that version of the database. They are implicitly connected. So we want them to be deployed together as a continuous thing. If it goes wrong, we want to roll it all back. If it goes right, we want it all to happen at the same time. We want to have full control over it. So model management is at the heart of making sure you can effectively and professionally target a digital twin environment or environments in a reliable and synchronized way. And that's the blog post, which you can read on the tech community, and it goes into a lot of detail about it. But in a nutshell, how you get to the solution of that is you leave the developers and the dev loops, and they're still working with these JSON files, and everything is pretty much the same. But rather than pushing to digital twin themselves, they push into like a Git-based source control. We use Azure DevOps. You might use GitHub or something like that. And then what happens off the back of that is there's a trigger, and a trigger is like a continuous delivery approach where every time something is merged, maybe we have it in a particular branch. So we might say only when things are merged into main do we actually, or a trunk branch, do we actually start pushing things out to production. So maybe we can have things in feature branches where we're just trying to hack away, just trying to get everything in line before we want to go and push to any productions. Maybe we have a dev environment that triggers off the back of our feature branches, but our production environments or our test or prod or pre-prod environments, they look at more of these trunk type or main type branches. But what that pipeline needs to do is it needs to get those Git those JSON files from Git onto disk, and then compare the ones that are committed to Git to the things that are actually deployed into the Azure digital twin. And really, there are two overall types of equality that we take into consideration. Version equality, which is making sure that the model is there and the correct version is there. And then also checking for version and property equality, which says that even if the model does exist, does it have all the same properties? Because there isn't really anything stopping you going into a digital twin, deleting a model and recreating it at the same name and version, but adding additional properties in there. So to be fully in control, you need to check all of those things. And if you find that there's an inequality in that, you can actually automatically deploy the updates, because there might be an upgradable sort of detection on there. For example, we go to the database, we find that version 7 of something is not available, but version 6 of something is. So we know then that this is just a brand new version that we can put on the database without really having too much of a concern. But if we go there and we find that actually our code says we should be on version 5, but there's a version 6 deployed, or something, there's already a version 5 there, but it's got a totally different set of properties on there, and something's gone very strange, we want to fail our build. We want to actually prevent there being a deployment at that point, because what we think we need in those JSON files committed to Git is not reflected on that Azure digital twin. So we know that if we just went ahead and said, whatever, we'll just go and deploy to it, we know we're not actually in sync, and we're breaking our covenant that we are only going to deploy together synchronized and controlled software and database structures. So that's the approach to model management in an absolute nutshell. There's a bit more detail about all this on the blog, and there's also some tools that you can get that are, again, listed on the blog. There's a .NET Global tool for doing this, so you can pull it into your existing pipeline, get it to do this work, and all you have to do is do like a .NET install, .NET tool install global Elastacloud.twin migration, and once you've installed that, you can just invoke it with a name of a digital twin instance, and it will go and check against the local file path and do all this work for you, and that's described in the blog post.
I just brought up the link to the blog post down there for people to go and check it out. I'll bring it up at the end as well. This is great. You basically apply DevOps to digital twins in a nutshell, right? Mm-hmm. I think that's fantastic. That's going to be very useful for lots of people. Before I let you go, Andy, you're an MVP. One of the things that we love, I particularly love with MVPs, is how genuine you are when you provide feedback to us, Microsoft. And actually, this is very useful because you tell us what's right, but you also tell us what's wrong. And I'm curious to know, from your perspective, being an early adopter of Azure Digital Twins as a service, going through the first 2 versions of that, what are your first impressions? What can you share about Azure Digital Twins that are good and that actually need improvement? I think it's going to be interesting for people to know as well.
Yeah, so, I mean, great opportunity, isn't it? This for me just to, it's all rubbish. But actually, no, it's not. It's really, really excellent service, and it's well performing. It's got a lot of features. There's new features coming all the time. It's got a good cadence to it. It's Azure as an org and from an outsider is a really incredible technology experience, because everything changes so quickly and we get so many new features all the time. It makes keeping up with it quite difficult, but it's something where we always know there's going to be good stuff coming. So when it GA'd, it was great, but there wasn't many tools. And like I said, we built some tools. Some of those tools then got built by Microsoft, which is great because you really want first party everywhere that you can, because they'll support it. You don't necessarily want unsupported stuff if you can get it from the first party. And one example of that is something like the Azure Digital Twin Explorer, which is now baked in to the portal experience, and you can go in and visualize your graph at quite a low level, like you see the digital twins themselves and the connections between them, and you can see some of the models that are deployed, and there's a model graph, and all of that stuff is great. And also at the same time, what's been really, really good is that Microsoft have been pushing out quite a few like gold standard almost ontologies. So one that we use quite a lot is the Real Estate Core 3.3 ontology, which is even open source, and Microsoft put it on GitHub, so you can just download the JSON files and get going with it. And that helps you describe a building, level, room, that kind of thing, asset, space, and all those connections between those things in a really effective way. And those things you can just get going in like 10 minutes, I guess. Like, it's really, really powerful stuff to get going and start to industry standardize data around buildings, which is really cool. But I think, like, because we know there are some types of gold standard, I think there's a link that could be made that isn't made, and the team could probably do a good job of helping this. If you know there's a gold standard, and you could effectively take a hash of the whole gold standard, saying this set of models with this hash is the gold standard of Real Estate Core, then you could sort of effectively deploy that to a digital twin, and you could get like a big old warning if you said that you wanted to deploy one of those, but something was missing from it. If there should be really a way and a tooling around the edges that combines these gold standards of ontologies that Microsoft keeps putting onto their GitHub, and proves or sort of guarantees somehow that you've deployed them and you haven't missed a file, or you've deployed them and you haven't then edited them but called them the same version number, and therefore it's a uncompliant set of digital twin ontologies compared to what the gold standard is. Because when you go to the extreme of publishing those ontologies, Microsoft's taking some responsibility for saying that this is a good set and that people can then learn to work with them and can build excellent queries against them that will work across any implementation of the same version. But then if you thought that you deployed one of those, and maybe you thought you deployed one of them even through the Digital Twin Explorer or something like that, only it had been modified subtly along the way, it's actually very, very difficult to work out that had happened. You'd have to go through every single file, you'd have to go through every single line of every property and check that everything was right. You could use the model management tool to do that by comparing it to a standard thing. But I feel like some of these that are Microsoft published could well be baked into the platform. So you could get like a big old green tick on the homepage when you logged into the Azure portal saying, yeah, this is Real Estate Core 3.3 and it rocks. And there's nothing wrong with it at all. And it's totally as it should be. And then it'll give you like quite a lot of confidence that if my query is written against Real Estate Core 3.3, I can just smash that query in and I'm going to get exactly what I expect out the end of it.
Fair. Totally fair. I like the way you position in that, where partners, MVPs like you are creating tools when they don't exist. And at some point you want the first party version. As a matter of fact, your feedback is well heard. I'll make sure the team hears it. I'm sure you already shared your feedback with the team. And something will happen there. I love that. Andy, great insights into your experiences with Azure Digital Twins. Hope you'll come back to the IoT show at some point for more about what you're doing, right?
Yeah, thanks very much. Thank you very much for having me on. It's been a real pleasure. Thank you.
And I will invite everyone to go read your blog post on the Tech Community blog, aka.ms/IoT show/Elastacloud, where you learn more about the tools that Andy just mentioned, about your experience, Andy, with Azure Digital Twins, and way more, because that's the msiotblog.com site, so you can have even more information. Thanks for watching the IoT show today. Andy, have a great night, and everyone have a great day. Hope to see you soon. Bye.